When we started the study a bit more than a year ago, we basically asked the question, how much wind potential from a power generation perspective do we have in the country, at what cost implications, and how do the different wind regimes that we have in such a large, spatially wide country like South Africa, with the east coast, the west coast, and the center having different wind patterns, how do these patterns fit to each other, and how can they help us smoothing out the volatility of wind supply if we distribute the wind fleet wisely across the country? Now, all these were open questions at that time. We didn't know the answers yet. I think we've addressed many of these questions, if not all of them, in this study. And we basically collaborated the CSR with ESCOM, with Sanedi, and with Fraunhofer IWES from Kassel to conduct a study whose result we want to present to you today. And we did that over the last year, and I think it was. I think you will be amazed of the results that we will see. I don't think it's an overpromise. So with these words of introduction, please hand over to the Fraunhofer team to guide you through the results. Thank you.
I'm glad to be being here and present you the results of our study, the Wind and Solar Resource Aggregation Study for South Africa. We are very glad and proud to work together with our partners in this challenging project. Well, in fact, the partners were from CSIR and ESCOM, Sanedi, and also the DTU in Denmark, which has carried out the data processing, the generation of the wind speed time series for all South Africa. My presentation will structure like follows. I will give you an introduction, mentioning a little bit about our institute, the motivation, why we do this study, give some hints about the objectives, and also give you a summary of results afterwards. Then I will hand over to my colleagues presenting data, methodology, and the scenarios we used, and finally coming to the results and conclusions. We will split this presentation in two parts. We are going until the scenarios, so the basis of the study, until the coffee break, and we'll jump into the results and conclusions after the coffee break. Starting with the introduction, our institute is called Fraunhofer IWES, which stands for Wind Energy and Energy System Technology. So we have two big sites, one in Bremerhaven, dealing really just with wind energy, focusing on offshore wind, and we in Kassel, it's the bigger site, we are focusing on energy system technology for all renewable energy. We are dealing with the grid integration, energy economics, and so on. The institute has been founded in 2009, but in fact it emerged from other already existing institutes, so we have more than 25 years of track record on renewables. Well, we in Kassel focusing on energy system technology, that makes, we want to make the Energiewende, the energy transition happen really in the real world, in Germany, but also globally, and that's the aim of our work. We are dealing with many different aspects of renewable energy integration and energy systems of tomorrow, including the behavior of electrical vehicles in the grid, but also for sure with solar power, wind power, biomass power, and so on, and especially how all this stuff can work together. For this study, I just wanted to show where the research team is in the organization of the IWES. In fact, in Kassel we have three big research divisions. Starting on the right-hand side, the energy process technology division deal with batteries and also power to gas, power to heat, and power to liquid technologies. we have a division dealing with system energy engineering and especially distribution grid integration stuff, load flow analysis and so on. And on the left-hand side, the division energy economy and grid operation is the division we are working in. Within this division, we have four departments: energy economics and system design, wind farm planning and operation, transmission grids, and energy informatics and information systems, which is dealing well with secure IT systems for energy-related application, virtual power plants, and so on. Well, in fact, the project team is recruited from the Department of Energy Economics and System Designs, which I'm leading. Within this department, we have 3 research teams: one about energy scenarios and system modeling, one about business model and market integration, and one about energy economics and system analysis. We have, within the team, we have members from all 3 groups to have all the knowledge together for this study. In fact, the study was carried out by about 7 persons. The project management has mainly done by Britta, which joins us today. And we have, as you see, many researchers contributing to this study. Why we are dealing with renewable aggregation studies in South Africa? Looking on a solar resource map worldwide, you see, as you know, South Africa has one of the best solar resources worldwide. But looking on the wind resource worldwide, you also see in South Africa you have many sites in dark red. That means also very, very good windy sites, which means, well, focusing on solar is good, but combine it with wind is even better. Compared to Germany, where we have already installed a huge amount of PV solar capacity, about 40 gigawatts. On the right-hand side, you see a lot of green colors. That means we have about 1,200 watt per square meter, kilowatt hours per square meter radiance per year. Looking on the left-hand side, that's South Africa in all the red. That means there are very good, much better resources than in Germany. That's again for solar, it's obviously. But looking on the wind resource, it's also the same. Germany is green and has low or medium solar radiation conditions, and wind conditions in South Africa has much better wind conditions than Germany. In Germany, we have already installed about 40 gigawatts of wind capacity, so we're really using very viable renewable for the energy supply in Germany. At the worse condition than in South Africa. But I think it's already now, and just looking on the figures for the PV penetration in 2 different countries. On the left-hand side, 2013, it's the penetration of PV in US, and on the right bar is the value for South Africa. You see in 2013 there was no PV installed in South Africa. But looking some years later, today you see US just doubled the penetration of PV solar to 0.4% of the total electricity demand, and this corresponds to 1% in the South African mix. So I think that shows that the South African power market can be very dynamic. has been proved by solar, but also can be proved by wind, and I think it can be even increased in the future. So, but doing this at a certain point, it's very important to know how wind and solar are behaving. This is just an example. In yellow, you see 5 example time series of solar. You see it's fluctuating, and if you do the average, it's much smoother. And if you do the same for wind, it's fluctuating. Every single side is fluctuating highly. By doing the average, you see you have a much smoother behavior. That means it's worth to think about aggregation aspects, and also to think about how to applicate renewable energy in the country and how to spread them over the country to gain such good smoothing effects. That was the motivation carrying out the study, which has the main goal to increase the fact base for renewable energy in South Africa, and to understand the behavior, the characteristics, especially this temporal spatial characteristics of the very viable renewable energies in South Africa. Some other goals was to generate data sets for other studies like the IRP or other studies, to have a solid basis for input data, and also comparable basis for input data, and also do some knowledge exchange between these two countries, Germany and South Africa. This all should result in more confidence in renewable energy and the capability for integrating of high shares of renewable energy. What has been conducted is a countrywide wind and solar data set covering the entire country with a 5 by 5 kilometer spatial resolution and 15 minutes temporal resolution. Well, within the wind and solar aggregation studies, we have the core study, which is really this aggregation stuff, but we carried out a lot of other studies or sub-studies, like for example a study for the Port Elizabeth region to show the aggregation and smoothing effects within this supply area. Also a curtailment analysis leading to a value how much a transmission grid substation can be overloaded by wind and solar data. We provided several data sets to different other studies, the IRP and also a case study. And we did some skills exchange. Some researchers visited us in Kassel. I was 3 times in South Africa for collaboration and joining conferences and so on. And I think it's a very important part also of the project. For some of the study, for example, the curtailment analysis, we will also present results today, but we mainly want to focus on the core study, the wind and solar aggregation study. Well, we have already carried out some publications in Science Scope at the CIREC and the Windava conferences. So we have also in the scientific sense already some good results.